Hello, dear all. Today we are going to talk about the very first module that we have got in communication theory. Okay, so communication theory, just to give a brief idea about it, it's all about the analog communication. We all know that basically there exist two different types of communication system. One is analog communication system, and then is the digital communication system. The only difference is the kind of input what we give to the system. If we are dealing in terms of analog signals alone, we call the entire communication system to be analog communication system, else it becomes a digital communication system. So in communication theory or principles of communication system, what is in general, uh, the title is, we'll be talking more about the different modulation techniques, the noise which gets added to the system at the receiver, and the different digitization techniques and all those things. So this is a brief idea about the communication system. So coming to the first module, which speaks about the amplitude modulation, the best book that we can refer to this is Communication Systems by Simon Higgins and Moher, 5th edition, John Ville India Private Limited, 2010 edition. Okay, so what are the different elements of a communication system? So, any communication, if we have to talk about the definition of a communication system, it is a process of conveying or transferring information from one point to another, or it is basically a process to establish connection or link between 2 points for information exchange. Okay, so any communication system can be represented in general as shown in the block diagram. If you see, anyways, we require an information source. We also require a transmitter. A channel is required. A channel can be wired or wireless. This is where the problem arises. The noise gets added, be it a channel wireless or a wired communication. Noise will always get interfered, and we have the receiver, and finally the information reaches the destination. Okay, so this is a very generalized block diagram. So I hope this is clear to you, the definition as well as the block diagram. Okay. So coming to the information source, what it is, the message or information to be communicated originates in information source. Message can be word, group or words, code, data, symbols, signals, etc. What is a transmitter? The objective of the transmitter block is to collect the incoming signals, message signals, and modify it in a suitable way such that it can be transmitted via a chosen channel to the receiving point. This is the whole idea behind a communication system. Okay, a transmitter basically. Coming to the channel, channel is basically the medium. It could be a physical medium or it could be a wireless as such. Here we are referring to a physical medium to initially have the basic idea about the channel which connects the transmitter with that of a receiver. The physical medium could be copper wire, it could be a coaxial cable, it could be a waveguide, it could be a free space or an atmosphere. Okay, what is a receiver? Receiver block receives the incoming modified version of the message signal from the channel and processes it to recreate the original form of the message signal. Okay, what is a signal? A signal is a physical quantity which varies with respect to time or space or independent or dependent variable, which is normally a time. Okay, an independent variable is normally a time. It is electrical waveform which carries the information. For example, if you consider m of t, considering m of t to be a message signal, it can be represented as a cos omega t plus phi, where a is the amplitude or peak amplitude, and w is the, or omega is the frequency, normally represented in radians per second, and phi is the phase angle, which is again a problem in our communication. Whenever there is a phase getting inserted to the actual signal, there occurs a lot of problem. Okay, so moving on to the next, what are the basic two different types of signals? Understanding this is also important. There are two different types of signals. One is analog or continuous signal. Second one is a digital signal. What is an analog or a continuous signal? If the amplitude of the signal continuously varies with respect to time or if the signal contains infinitely many number of amplitudes, it is called an analog or a continuous time as well as voltage signal. What is a digital signal? A digital signal is one wherein which contains only two discrete amplitudes, which could be a high or a low, or it could be in terms of TTL if I say plus 5 and 0 volts. With respect to the communication, signals are classified into two. One is baseband signal, other one is a band pass signal. What is a baseband signal? If the signal contains zero frequency or near to zero frequency, it is called as a baseband signal. The best example is a voice signal. So normally when we say voice or audio signal, we say that the frequency ranges somewhere from 0 Hz to 20 kilohertz. That's the audio frequency range. But a voice frequency range will start from very near to zero value, which is around 200 or 300 Hz, and goes up till around 3.4 kilohertz, or max to max I can say 4 kilohertz. So you can just see the frequency ranging very nearing to zero. So those kind of signals are called baseband signals. So it is always our assumption that the input signal what we give is a baseband signal, which is kind of untouched signal as it is, unprocessed signal. Okay, it could also be biomedical signals and lot many things. Okay, so coming to the bandpass signal, it contains a band of frequencies far away from base or zero, and such a signal is called a bandpass signal. Examples could be AM signal itself. And after the modulation, whatever the signal we get, we say it is a bandpass signal. But this doesn't mean that the input signal need not be a bandpass, or it should not be a bandpass. Even an input signal what you give to a communication system can also be a bandpass signal, which contains a band of frequencies. The example which I gave just now for a voice signal ranging from 300 Hz to 3.4 kilohertz. If you take some other signal which is, say starting from 4 kilohertz and goes up till 16 kilohertz, that also becomes a bandpass signal, but it is a little bit far away from the zero frequency value. Okay, what is a message? It is basically a sequence of symbols. Example, you can just type a message called Happy New Year. We have been doing all these things since we started using the mobile phone. Even in when we try to message using a email, we do it. So such a kind of thing is what is message. What is the information? Whatever the content that is there in the message is what is called as a information. It is basically inversely proportional to the probability of the occurrence of the symbol. Okay, so this point is quite important, but for the analog communication part, this may not be more important for us, but still as a basic we can discuss about it. Information is measured in bits, decits, or nats. These are normally few units that we can use for the measurement purpose. Okay, what are the limitations of a communication system? So there are many. To name few, there is one technological problem. That is, to implement a communication system, transmitter, receiver, and channels are always required, which requires hardware. And the communication system obviously becomes more expensive, and it will also be complex depending on what kind of signals we are dealing with and what is the distance between the transmitter